and this is being recorded now. So we want 2x cubed minus 3x squared plus 5x minus 4, and the question says express that in nested form. So what you do is you look at the highest power and you put brackets one less than the highest power, so that's cubed, so I would just bother with 2 brackets, and I'd start by writing 2x, and then you've got a minus 3 here, so I put a minus 3, close the brackets and put an x, and then you go to the next power, so that's plus 5, close the brackets and put an x, and then minus 4. Right, so let's just go along the brackets. So we add 1 for an opening bracket and subtract 1 for a closing bracket, so we go 1, 2, 1, 0. We've got to 0, which means our brackets balance, so there's nothing wrong with the brackets. And then just let's think about expanding this. If I expand the first bracket, I'm going to get 2x squared minus 3x. And if I then so let me do that. 2x squared minus 3x plus 5 bracket x minus 4. So I'll now expand that bracket. I'm going to get 2x cubed minus 3x squared plus 5x minus 4. Okay, so that means that we've got from this position here to this position here, and then we've done a sanity check which gets us to there. Okay, and the reason you do this is that it's computationally much more sensible. It's much quicker to do that computationally, and that's what we're looking at in nested form. And actually, just looking at question B for the same question, it's saying what's the value of this. Now I know you've got calculators and all the rest of it, but this is saying what's the value of this when x equals 3. So 2 times 3 is 6 minus 3 is 3. 3 times 3 is 9. 9 plus 5 is 14. 14 times 3 is 42. Minus 4 is 38. Okay, so there, 38. There's your answer without even a sniff of a calculator. Okay, that was not hard calculations to do that. And if you ask me to evaluate this expression, where's the mouse? Come on, mouse. There we go. If you ask me to evaluate this expression when x equals 3, I would struggle to do that, but evaluating this expression when x equals 3, piece of cake. Okay, Sarah Carnell asked before we went in how you would write question 8 in the tutorial in baseline, and here's the answer. You'd write SQRT brackets 2v divided by pi h, and baseline has pi for pi, and obviously the h was in the question, and then it's minus h squared divided by 3, and that's how you would type this expression into baseline. That's how that would go in. Okay, and there were a couple of questions on the tutorial questions, weren't there? I think that will be a good enough statement. Find C when A is equal to 3 and B is equal to 4. So C squared will equal A squared plus B squared. So then you could say that that is equal to 3 squared is 9. I've said 3 cubed, haven't I? Not 3 squared. So 3 squared is 9. So that's going to be 9 plus 4 squared is 16. Okay, that is going to equal 25. So C equals plus or minus 5, and then you need finally answer WER, answer, and I tend to put a colon, C equals plus or minus 5. Okay, that's how you would answer that question. Okay, and the other questions are going to be similar. So you're actually calculating a numerical value at the end for question 1, yeah, for all of those, and question 2. Right, question 2, we are moving objects around, and so for RT, R1, R2, you'd write those as yeah, I've said that there. Write R1 as R1, etc. So baseline will understand that when you write R1, you actually mean R subscript 1. Okay, and yeah, so the rest of this, it looks, you know, it's sort of just algebraic manipulation. I think we're okay with that.
Tom, a question's been asked about whether we could move the deadline till Thursday. However, have the students now got, what's the deadline time on Wednesday?
Midnight on Wednesday.
Midnight. So basically, you can still use your PAL session on Wednesday because you've got till midnight to complete your tutorial and get it in, okay?
Yeah.
Thanks for that, Tom.
Yeah, okay. Right, I'll stop sharing this screen for now at least. Okay, and I'm happy to, you know, we're into questions now. So everybody who's going, that's fine. You can blow. And anybody who has got questions, this will be a fine time to ask them.
Kevin's asked if you can go through a few of the questions.
On the...
is it the tutorial, Kevin, or the exercise textbook?
Textbook, yeah.
Kevin. The tutorial.
Okay, so I'm not going to tell you too much about the tutorial, Kevin, just so you know, because you're meant to do that, not me. Right, is that visible to everybody? No, I'm not sharing the screen, so let me share my screen again. Share screen, that one. Share it. Okay.
Yeah, you're sharing.
And I want that one. Yep, there we go. Okay, so this is on equations. I've given you an example of how I would expect you to answer question 1. 1b, 1c, 1d. Yeah, you're just putting numbers into these to get the values. 1d is slightly different because I want RT given 1 over R1 and 1 over R2. So what I would do here is I would start by saying find RT given that. So I'd probably just copy that and stick that in because that's a statement of the problem. Okay, find RT given that. Okay, and then what I would do is I would say that 1 over RT is equal to 1 over R1 plus 1 over R2. Okay, then what I would do is I'd probably write something like so, or something like that, you know, just as you would do it on paper. 1 over RT, and I've put TR there, haven't I? So that's 1 over RT. And am I still recording this? I am, so I'm not going to give you the whole answer, is equal to, and now what I'm going to end up with is R2 plus R1 divided by R1, R2. Right, I'm doing that off the top of my head, and the syntax of that is wrong because I need some brackets. So I need to say the denominator is equal to that, and just because these two are added, I'm going to change the R1 and the R2 round because that looks sort of tidier. Okay, so 1 over RT equals R1 plus R2 over R1 times R2, which means that, so I'll probably put another so there, and then I would say RT is equal to, and now I can do it the other way, so it's R1 R2 divided by R1 plus R2. Okay, and now you can put the numbers in, you will get a value, and you can then you'd put at the end, you'd have answer colon and whatever the value is. I'll put 66, but that is not the right answer, just so you know. Okay, so that's how I deal with that. Okay, rearrange, well, how you'd rearrange question 2 is similar to what I've just done here. It's that sort of logic that I need to see there. So you'd start with 1 over RT is equal to those, then you'll mess that about and you'll end up with RT is equal to, and you can probably see the shape of what the answer is going to be from what I've done there. Okay, so that's 2A, 2B, yeah, again, same sort of thing. You're just going to end up with u is equal to an expression involving s and a and t. That's fairly straightforward. This one is less straightforward. You're going to have to think about this one a little bit, but I will give you a clue. It's a quadratic equation. Okay, D, yeah, I mean, again, that we went through that in my breakout room, and I suspect the others did as well. Okay, we covered this one as well, so nested form. So just to remind you, whatever the highest power is, put in one fewer brackets than that, and then it's going to be, just watch this, you'll see it as I go along. So it's going to be 2x minus 3 brackets x plus 5 brackets x minus 4. Okay, I need a little bit more description than that, but basically that's how the answer comes out. So just do that again. I've got highest power is 3, so I'll put down 2 brackets, so then it's going to be 2x minus 3 brackets x plus 5 brackets x minus 4. It's that easy. And then this section B says evaluate that when x equals 3, which is what I did earlier. 2 times 3 is 6, minus 3 gives you 3. 3 times 3 is 9, plus 5 is 14. 14 times 3 is 30, 42. Minus that is 38. You know, I couldn't do this in my head, but I can do that in my head. You see the point? Okay. C and D are basically the same question, but with different values. Algebraic division. We probably want to do one of those, don't we? Let's do that. Let me just move that off and get the whiteboard up. So let's have a whiteboard, and let's clear the screen. And if I'm going too fast, please feel free to stop me. But we're going to do algebraic division. So what it's saying is divide x cubed minus 6x squared plus 11x minus 6 by x minus 3. If you have your own way of doing this, that's absolutely fine, don't change it, but this is the way that I would do it. So I would start by doing the old-fashioned divide, and you're going to get x cubed minus 6x squared plus 11x minus 6 divided by x minus 3. Okay, now what we're going to do is we want to know, what do I have to do to x to make x cubed? And the answer is obviously multiply by x squared. So I'm going to multiply x minus 3 by x squared, which will give me x cubed minus 3x squared. And this is going to give me an x squared, so I'll put it there. And then I'm going to subtract this term from this term. So x cubed minus x cubed obviously is nothing. Minus 6x squared minus 3x squared. That sounds like a disaster, doesn't it? So I'm just going to give the answer minus 3x squared, and I'll go over that again. So I've got minus 6x squared minus 3x squared, which means that's plus 3x squared. So I've got minus 6 plus 3 gives me minus 3 in the end. Okay, then the next thing I'm going to do is I'm going to bring that 11x down. So I've got plus 11x. Okay, so that's the first term dealt with. Now we do the next term. So the question is, what do I have to do? Right, let's do, so what do I have to do to x to get minus 3x squared? And the answer is multiply it by minus 3x. Okay, so I'll say that again. What do I need to do to x to make minus 3x squared? And the answer is multiply by minus 3x. Okay, now if I go z, that disappears, but I'll put it back in again. So that was minus 3x. So I'm multiplying x by that, so I'm going to get minus 3x squared. And now I'm going to multiply minus 3 by minus 3x, so that's going to give me plus 9x. Okay, just say that again. So I've got minus 3x. I saw the videos from last week, and moving the mouse doesn't help much. So I've got minus 3x, and I'm multiplying x minus 3 by that. So I'm going to get minus 3x squared, which is what I've got there, and then I'm going to get minus 3 times minus 3x, which is plus 9x, which is what I've got there. So now just remove those lines, ding, 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 and go to black. So I'm going to subtract these two quantities. Obviously minus 3x squared minus minus 3x squared, they will disappear. 11x minus 9x, that's nice and easy, that gives me 2x. And then I'm going to bring the minus 6 down. Okay, so I'll get a minus 6 there. So I've got, let's have the green pen. What do I do to x to get 2x? Well, the answer is multiply by 2. So I'm going to have plus 2 there in a second. So let's just get rid of those things and say that's plus 2. So 2 times x is going to give me 2x. 2 times minus 3 is going to give me minus 6. So obviously that is 0. So that means that x cubed minus 6x squared plus 11x minus 6 divided by x minus 3 is equal to exactly x squared minus 3x plus 2. So let me just write that down. Just slide that up a bit. So I can say that x cubed minus 6x squared plus 11x minus 6 divided by x minus 3 is equal to x squared minus 3x plus 2. Okay, and there you go. I've given you yet another answer. If this wasn't 0, if we had something here, I'll just say something, that would be a remainder, and the remainder would find its way into there. But in this case there is no remainder, so that means I don't have a remainder at the end of it. Okay, and that is an algebraic division. And it says in the question, let me just bring the question back in again. It says in the question, if there's a remainder, write r colon and then whatever the remainder happens to be. Okay, so that's question 4a. 4b is the same, 4c is the same, 4d is the same. Okay, somebody going to speak?
Yeah, Tom, sorry, I've just had a question in the chat. How would you write a subscript in baseline?
You don't need to. You just write. So basically, if the subscript, if you're trying to write R1, for instance, R subscript 1, just write R1, and baseline understands that a number immediately following a variable with no operator means that you're talking about R1. It's not R times 1 or anything like that. So if you were writing, let me go over to here and get a pen. Come on, where's the mouse? Do you know these invisible mice, they're such a pain. So if you were writing, if you wanted to write R1 plus R2 in baseline, you would write R1 plus R2. So you don't bother with the subscripts, baseline will understand that. Okay?
Lovely, thank you very much, Tom.
Right, so we were just looking at these questions, we're doing the divides and all that stuff. Okay, next thing that you need to look at is factorizing. We've got x cubed plus 2x squared minus 4x minus 8. Okay, and we need to factorize that. So what I'm going to do for simplicity, I'm going to write brackets, brackets, x plus 2 brackets x minus 4 brackets x minus 8. Okay, so I'm just going to try some values in here. So let's try the value. If I put 0 in, so all the x's become 0, I end up with minus 8. So let me do a table. So I've got x and then the expression x cubed dot 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 dot. Okay, so when x is equal to 0, this whole expression equals minus 8. Okay, so that means that x equals 0 is not a root of this equation. When x equals 1, 1 plus 2 is 3 times 1 is 3. Minus 4 gives me minus 1. Minus 1 times 1 is minus 1. Minus 8, so that's minus 9. So x equals 1 is not a root. So let's try x equals minus 1. So if I stick minus 1 in there, I'm going to get minus 1 plus 2, which is 1. 1 times minus 1 is minus 1. Minus 1 minus 4 is minus 5, times minus 1 is plus 5, and then minus 8 means that's minus 3, so that's not a root. So let's try, I don't know, should we try minus 2, just looking at this? So that would disappear. Minus 2 plus 2, that is 0, so that whole term disappears. And then I've got minus 4 times minus 2, which is plus 8, and then I've got minus 8 there, so ta-da, that is a root. Okay, so that's important. Let's even do this in red to show how important it is, because what we've done by guesswork is we've found one of the roots. Okay, so knowing one of the roots of this, which is x is equal to minus 2, so the root is x equals minus 2, so the factor is x plus 2 equals 0. So now what I'm going to do is I'm going to get x cubed plus 2x squared minus 4x minus 8, and I'm going to divide that by the factor x plus 2. That's going to give me a quadratic, so I'm going to get an x squared and some other terms. Okay, and once I've got an x squared, I can just use the equation or inspection or whatever, and that then means I will get the 3 factors of this cubic equation. Okay, any questions on that? Because that's how you'll deal with question 5 on the tutorial. Obviously, if you do have questions, bring them along to the tutorials. Okay, question 6. Mouse, where are you? There you are. Let's move that up. So question 6 is changing things about again. So we've got f is equal to 1 over 2 pi square root of LC, which if you're planning to do electronics next year is about an AC current through a choke, through a coil. You've got a coil like that and you're putting AC through it, and that's the equation for what's going on. And what do I want to do? I want to get L as the subject. Okay, so what I'm going to do first of all is multiply both sides by root LC, so I'm going to get root LC. I'm also going to divide both sides by f, so that's going to equal 1 over 2 pi f. Okay, then you take the squares and do all the other stuff, but I mean that's fairly straightforward. B's.
Tom?
Yes.
Sorry, I'm so sorry. Just had a question. Would you mind moving the board down again so I can take a picture?
They should have done it already. I'm going to
Or
win.
if you do mind. I don't know.
No. Okay.
Lovely, thank you.
So that's probably the bit we want, isn't it?
That's the bit I think we're looking for. Right, folks, get your pictures quick.
Yeah, quicko. This is on the video. Yeah, so don't worry. It is videoed.
Yeah, we've got it. Yeah.
Right. Okay. Right. So question 6. I think we're okay with question 6. A, B, C, and D. Yeah, they're all much of a muchness, but the equations get harder. Question 7. Yeah, is slightly messy, but it's not an unrealistic question. So what you're doing is you're solving the square root of x plus 2 plus 2x equals 4. Okay, this is only made complicated by this square root here. Now, what we've been saying all the way through the last 3 weeks is whatever you do to one side, you have to do to the other side, but it's the whole of one side. So if I say, oh, I've got a square root here, so why don't I square this side and square this side? Okay, this side is nice and easy, that's just 16, but well, look what happens when we try to square this. I'm going to get this squared, so that'll be x plus 2, because it's squared. Then I'm going to get this times this, so that's going to be plus 2x square root of x plus 2. Then I'm going to get that times that, so there are going to be 2 of those, so plus 2x times the square root of x plus 2, and then I'm going to get the 2x squared, so that's going to be 2x all squared, you understand, so it's 4x squared equals 16. Okay, is that good? No, it isn't. That makes life a lot worse. Okay, so what am I actually going to do? Well, simple thing is, go away, I'm going to get rid of that dot. I'm going to go back to this equation. I'm going to say the square root of x plus 2 is equal to 4 minus 2x. Okay, and now what happens if I square that side, I get rid of the square root, and if I square that side, I get a quadratic. I can solve a quadratic, we know how to do that, so what I'm saying is make sure you just get the, this is called the radical when you get the square root, so get the radical by itself and then you can do the squaring and life becomes easy. And if you don't, life becomes very painful and you don't want to go there. Okay, so just think about your equation before you do that. So that covers 7a. 7b, obviously you're finding the roots. Oh, 7a and 7b, you're finding the 2 roots. 7c and 7d, same sort of thing, but with different equations. So I don't think they should represent too much of a problem for you. Question 8. Find the value of x for the given these equations. Yeah, okay, these are just log equations, but you are going to end up with a quadratic. Yes, you are. And then there's the 8c and 8d. I'm not going to touch that just now, but I will make a quick video on it just to explain how using the modulus. Just so you know, let me drag that back in. Somebody has already asked this question. I don't want it full screen, so let me just move that. I'll make a short video on that, I think. Just so you've got 2x plus 3, and obviously x here can go negative, but here if x is negative, so this thing becomes negative, the modulus means it's always positive. So we need to think what that means. But I'll make a short video on that. I think that's the best way to do that. Because personally, I wouldn't understand it without some pictures. So that's what I'll do. I'll make some graphs and so on so you can see what happens. Okay, is that enough of everything? Are you bored to death, or have you maths out? Let me stop sharing. Oh no, let me minimize that and look at the comments. Sorry, Kevin, I don't understand your last question. Where will the video be? Yeah. Okay, so the video of these 2 sessions, the first, the 2 sessions today, that video will be on baseline under lectures. Is it called lectures? I'm still sharing the screen, aren't I? Yeah, so let me show you. So under resources, yeah, it's called lectures. So at the moment we've got numbers and algebra, and by, I don't know, depends how long it takes me, but by sometime tomorrow probably we'll have the one on equations and the exercises. And then when I make another one, I'll probably put it under videos here. So the one on equations, I'll stick that under videos, but I'll make an announcement so you know where it is. Okay? Right. Anybody else? Any other questions? It's Nicole. Hi, Nicole. You can hear us now, can you? Okay, any other questions? Or is lunch calling you like it's calling me? Question 6a. Okay, let's have a quick look at 6a. Kevin, you're being very thorough, and that's great. So 6a. Okay, yeah, I just did that. Let's just have a look at the whiteboard. Yeah, there we go. That's 6a, isn't it? Yeah. So here's 6a. So f is equal to 1 over 2 pi root L over c, And what I was saying is, if anybody who's doing electronics, that's a coil, and you're putting an AC current through the coil, and that's the equation of that. So what you're trying to do is to get L as the subject, which is the impedance of the coil. So multiply both sides by root L over C and divide both sides by F, which effectively, let's change my pen colour. So effectively what I'm doing is I'm moving the F down to there and I'm moving the root LC up to there. Do you see what I mean? So that means I've got root LC is equal to 1 over 2 pi F. Then I can take then I can square both sides and do the other bits, but I'm not going to do that for you. That's your problem. Is that okay, Kevin? 1C and 1D. Okay, let's have a look at those. 1C, right. 1C is, okay, this is fairly straightforward, 1C. So K is equal to E to the EA over RT. So all of that is the exponent. Okay, and find K when EA equals that and so on. So that what you'd say is that you're typing this into baseline, you put the values in. Okay, yep, so that's 1C and 1D is similar. So let me just, I will show you this, but I think it's on the video as well. Don't go max, go min. I've just heard my doorbell ring, and that's my new GoPro Hero 10 camera arriving. How exciting is that? Okay, so that's how you do it. So you'd start by stating the problem, you'd get that equation, you'd calculate you put the right hand side over a single common denominator, then you can invert both sides so you get RT is equal to whatever it is, and I've put here the answer equals 66, which it isn't. I'm just saying that that's how you'd state the answer. You just give a number at the end. Okay, so that's 1D, and then 2A, yes, okay. So with 2A, again, you do the similar sort of thing, only it's a bigger common denominator. And here, subscripts, we've got R1, write that as R1, like that. Okay, is that enough for one day? Right, when I state the question on baseline, yeah, could not decode that. Alright, leave that with me. I'll have a look at that. Yeah, so obviously baseline is trying to do something and it finds it can't decode it. Just leave that with me. I'll see what that means, because I need to go through the questions and see how they operate. Okay, any other questions? One C, 1D and 2A. Kevin, have we not just done that? Ah, okay, well listen, it's in the video. So you'll find it in the video. Okay. So I have to go back and check, just checking if I've missed anything. Yeah, so just wait until I got the video, which will probably be tomorrow. It takes quite a while to do these things, but you'll see it in there. If you don't understand it, then either email me or bring the question along to the tutorial. Either is fine. Okay, but once the video's up, you can have a look at it, yeah. Okay. I think we've probably had enough for one day, haven't we? I'm going to stop sharing the screen now. Any other questions before we close the session? Don't know about anybody else, but I'm starving. Okay, I'm going to close it now, and I'll post these videos tomorrow, and then we can look at any questions that you might have next week. All right. Our baseline test always midnight. Yes, there will be always midnight. The thing is, Kevin, there's one of the tutorials doesn't start until midday on Wednesday, so yeah, it's always midnight. Okay, right, goodbye everybody.